this next problem, we have this 3 that needs to be moved to the right-hand side. So we will begin by adding 3 to each side of this inequality. That gives us absolute value of 5x plus 2 is greater than 11. Now we have an absolute value greater than 11. That's going to use the third property that we have at the top of this page, where we're going to say 5x plus 2 is less than negative 11, or 5x plus 2 is greater than 11 itself. Smaller than the negative value and greater than the positive value. Split up with or. You need to do it this way. There is no other way to remove that absolute value. Now we have two inequalities that can be solved rather easily. We begin by subtracting 2 on each side of each, leaving us 5x is less than negative 13, or 5x is greater than 9. And then dividing each by 5, we have x is less than negative 13 fifths, or x is greater than 9 fifths. And whenever you have an absolute value with a greater than problem, you're usually going to have an answer set that has two regions in it. We are going to write this in interval notation as the interval from negative infinity up to negative 13 fifths, united with the next interval beginning at 9 fifths, going up to positive infinity. Any value in either of these regions will work in the original inequality. Any value not in these regions will not work. For example, we are saying 0 is not part of the solution set, and if we take 0 and substitute it into the original problem, we get 5 times 0 plus 2, that's 2. Absolute value of that is still 2. 2 take away 3 is negative 1. Is negative 1 bigger than 8? No. It isn't. Therefore, 0 is not part of the solution set, and we didn't think it was going to be because we did not have that listed as part of our solution set. Okay, the first thing we want to do here is subtract 8 on each side so that we can isolate the absolute value. This is going to give us the absolute value of x plus 5 is greater than or equal to negative 6. Now, absolute values represent distance. Distance is always positive. You want to be on the lookout for negatives. We do not want to apply the properties in this case. The left side, as you well know, is positive, and we have a positive greater than or equal to a negative. When is that the case? The answer is always. So here our solution set will be all real numbers, or in interval notation from negative infinity to positive infinity. In this next problem, you can see that the left side is positive and the right side is negative. When is a positive less than or equal to a negative? The answer is never. So we have the null set symbol, or we can write the empty set symbol. There is no value of x that will work in either of these two or in this problem. We had all values of x working in number 4. So whenever you have a negative value on the right hand side after you have isolated the absolute values, that is the clue that you're going to be in one of these special circumstances. Let's begin this next problem by subtracting 8 on each side. This will leave us with 5 times the absolute value of 2x minus 1 is greater than or equal to 11. We then will be dividing 5 on each side of this inequality. This now leaves us with the absolute value of 2x minus 1 is greater than or equal to 11 fifths. Now we have the absolute value isolated by itself on the left. Now is the time to apply the property to remove the absolute value. This will give us 2x minus 1 is less than or equal to a negative 11 fifths, or 2x minus 1 is greater than or equal to positive 11 fifths. And I'm going to slide this up here because that is really where this problem is now beginning. We now want to add 1 to each side of this problem. Well, on the right, it's easier to add this as 5/5 so that we have a common denominator whenever we add fractions. Now what we are left with is 2x is less than or equal to -6/5, or 2x is greater than or equal to 16/5. We now want to divide each side by 2. And some of you may not like this compound fraction here. If you want to think of this as multiplying by 1/2, that works just as well. And then you can cancel here. What we're going to have is x is less than or equal to -3/5, or x is greater than or equal to 8/5. And writing this in interval notation, we have -infinity to -3/5, including the boundary point, united with 8/5, which we include, on up to +infinity.